Good evening. My name is Rachel Martin, and this is Better Residential Energy Forecasting, scraping public records and data sources for predictors of electricity and demand. With me tonight presenting is Andrew Jayansky and Austin Burns. While we're all students in the MIS Master's Program, in the early stages of our project, we quickly realized that between Austin and Andrew, there was another commonality. Both Andrew and Austin worked for electric cooperatives. It was from this realization and an idea pitched from Andrew that our team decided to pursue a project that would benefit nonprofit electric cooperatives in Oklahoma. In our research stage, we found a breakout session from a SAS symposium in 2016 that became the core of our project. Old Dominion Electric Cooperative presented a project to manage and analyze their system's electric consumption data, using variables such as weather and population growth to forecast future usage and manage costs. Within 2 years of implementation, ODEC reduced its rate 4 times, thus saving members millions of dollars. Old Dominion Electric Cooperative services Virginia, Maryland, and Delaware. With such a wide service territory, our group was curious as to what forecasting would look like in a more sparsely populated area. Therefore, we determined to use our resources to test Oklahoma. We will be using data from Oklahoma Electric Cooperative. OEC is a member-owned cooperative located in central Oklahoma that serves 57,000 metered service locations. Andrew was able to secure permission to use some anonymized company data for this proof of concept project. We identified 3 main business problems in this project. The data we are collecting will aid in operational reporting, rate design, and demand forecasting. Our primary objectives are to explore OEC's usage and service location data, scrape real estate data from Cleveland County Assessor's Office, and prepare integration with future predictive models. The future primary goal of this project is to eventually build a forecasting service for OEC. Our project scrapes data from multiple data sources, including customer records management, meter data management system, and geographic information system, or mapping data. Our aggregated consumption data will serve as a stand-in for individual service location consumption data that will be used for further analysis. Now, Austin will discuss the next steps of our process in our data preparation and collection.
Thank you, Rachel. We wanted to scrape the Cleveland County Assessor's Office for useful predictors of electric use, like square footage of a house. Cleveland County had too many service locations, so we needed a smaller sample. Acme Substation serves 3,227 service locations in Norman and Moore, Oklahoma. Every service location served by Acme Substation was within Cleveland County, making it an ideal test case. Before collecting any data, we ensured that we are legally authorized to use the data for our project. All real estate data is public information, and Andrew checked with the attorney on staff for authorization to use the OEC data presented. We gathered our data from Cleveland County Assessor's website and Oklahoma Electric Cooperative. After collecting our data, we quickly realized that trailer parks, apartment complexes, and empty plots of land were not going to add value to this project. In the cleaning phase of data preparation, we removed the data we deemed not beneficial to this project. In the OEC data, we removed some records based on service status. We did not need to scrape for service locations that are, for example, retired or not yet connected yet. In the service address field, we used regex to clean the OEC provided addresses, as some of them had descriptive words for the co-op, such as barn or shop. Appended to the address field in phase, substation, and feeder, we filtered out nulls prior to joining and scraping. After cleaning the OEC service location data, we went from 32,172 locations down to 30,583 locations. Since our project scope was for Acme Substation, we filtered out all out-of-scope data and ended up with a list of 3,227 locations to scrape. After cleaning and scraping the data, we joined the 2 data sources. We stored our data in text files. Usage data was extracted from OEC's meter data management system with Python code and an API. OEC's attorney would not let us share that, but one problem we found was that the meter data management system had a software bug. No weather data was present in OEC's readings database. We had to omit the weather component. This is an example from the Cleveland County Assessor's Office. The tables make it much easier to scrape the data. The most relevant fields are cooling, total finished area, stories, year built, and market value. We went ahead and collected all fields from this site except for the sales table. Next, Andrew will discuss the results of our findings.
Thank you, Austin. I'm pleased to pronounce the project a moderate success. After rooting out errors in our code and optimizing, crawling to each service location on Acme Substation and scraping data from the property data card for each took about 13 seconds per record and just over 11 hours total. And it returned useful results for 83% of those records. We were also pleased that we would be able to respectfully not abuse the server resources for the website since our scraper worked slowly. However, prior to sampling, we had no way of knowing what the quality of the data in the property data cards would be, and we were disappointed to find that it was not complete. Most disappointing of all was the field cooling type. We had hoped to discern which properties had electric heat versus gas heat, but we're simply going to have to turn elsewhere to collect that information. The histogram on the right shows that out of 3,227 service locations searched and 2,667 records returned, only 973 of them returned an HVAC type at all, and nearly all of them were classed simply as central heating and air, which is not particularly useful for discerning anything. At this step, we were also interested in that missing 17% of the records. In those cases, we found that a service location does not always equal a property, and neither a service location nor property always equaled a building. In the Assessor's Office website, multiple buildings may exist in a single property data card, as each one is an improvement on the land. So some service locations were duplicate properties or else needed human eyes to disambiguate. Now, the square footage and market value were the greatest successes that we had. The data scraped for these two fields was not only complete and distinct for the properties searched, but they also stood up to ground truthing. The average service location on Acme Substation is a small family residential structure valued between $140,000 and $160,000. And because the market value correlates with square footage, the histogram plots for both were left skewed and leptokurtotic, thanks to a scattering of mansions, businesses, and other expensive properties. From the consumption data, we used the R visualization package ggplot2 to plot the hourly consumption data for Acme Substation, all 8,760 hours over the course of the year. In the process, it was easy to find the demand for each month for that substation. And when we zoomed into late August, we could easily see that peak system demand for Acme Substation in 2020 came between 4 p.m. and 5 p.m. local time on August the 28th. 16,713 kilowatt hours were pulled through the substation during that hour and distributed to OEC's members. Consumption controls implemented in the 2 hours immediately prior to that peak might have reduced OEC's total system demand, which is important because that peak demand sets the rate structure that OEC will pay to purchase power from their G&T utility over the entire next year. Compiling the summary statistics for our most important attributes together, aggregated consumption for Acme reflects that peak that we had found visually. It's also clear that market value and taxable value were highly correlated, and only a single should advance into the forecasting step. Total finished area in square feet also covaries with market value, and we're going to have to do some testing to determine if it's a more useful predictor of consumption and demand in the future. And that future work is going to move away from this constrained data and onto on-premise data at OEC. After analyzing all of the consumption data for each substation and building reports for those stats and visualizations, I will be switching the consumption data from these aggregated values by substation to the service location values for each individual service location, each individual house, in other words. Then I'll be using the features of each property to predict demand and consumption for those individual locations on OEC system. This will be entirely open source and shared to the statewide Association of Electric Cooperatives at the next IT meeting. Ideally, every nonprofit cooperative in the state will be able to copy some of what we've done and start forecasting similarly. helping us to all deploy load management programs and better designed rates everywhere. And with that, that's the end of our time. I do appreciate your time, however, and your feedback. We can all be reached at the email addresses below.